This lesson is on solving equations in quadratic form. We've done a lot of practice on solving quadratics, such as this one. We would factor into x minus 9, x plus 1, and then of course set each of those equal to 0 to solve, giving us our solutions of 9 and negative 1. What we're going to do now is we're going to solve equations that are in the quadratic form that are not necessarily quadratic. For instance, on my first example, I have x to the fourth, meaning this is a quartic problem. And in a quartic problem, if you have to the fourth and then to the second, we can use something called U substitution. And U substitution is just a fancy way for us to be able to write this as a quadratic, factor it, and then plug a value back in to actually solve. What I mean by that is I could write this as x squared squared minus 8x squared minus 9 equals 0. Look at this original question where I have some value squared minus 8 times some value minus 9 equal to 0. So what we're saying here is we could say that u is x squared, so u being just some other variable. Meaning I can write this as u squared, because I've replaced x squared with u, minus 8u minus 9 equals 0. Now look at how I factored that when it was an x. I'm going to factor u minus 9, u plus 1 equals 0. Oops, I said u, but I wrote x. That should be a u. Now, u is actually x squared, so I'm replacing u with x squared. And now I can continue from here. So I used my u substitution to put it in a quadratic form. I factored the quadratic form, and then I substituted the value for u back in. And now I'm going to continue to solve. Remember, I'm looking for up to 4 solutions. The first one is factorable because it's a perfect square minus a perfect square, so x plus 3, x minus 3. The second one, not factorable because of that plus sign in between. So this is my most simplified form. To find the solutions, I would set each of these equal to 0. Setting x plus 3 equal to 0 gives me negative 3. X minus 3 equal to 0 gives me positive 3. Setting x squared plus 1 equal to 0 means that I have to do a little bit of math. And when I take the square root of negative 1, I get plus or minus I. So that would be negative I and also positive I. So I have 4 solutions. 2 are real solutions and 2 are imaginary. This is very similar to that last question because again I have to the fourth and then to the second. So of course u would be my x squared again. So this would be u squared minus 3u minus 4 equals 0. This would factor into u minus 4, u plus 1. Now that it's factored, I would go back and substitute the x squared in for u. And then of course I would continue to factor if possible. The first factors into x plus 2, x minus 2. The second does not factor, but just like in our last question, we're going to set all 3 equal to 0. Setting the first equal to 0 gives me negative 2. The second gives me positive 2. The third, again, just like on our last question, I get x squared equals negative 1, so x equals plus or minus I. So it's negative I and positive I. This one is a little bit harder because as you can see, we no longer have an x to the fourth or to the sixth or whatever the even exponent would be. Now we have some fractions. But I could rewrite this as x to the 1/3 squared plus 8 times x to the 1/3 plus 7, which means the u in this case would be the x to the 1/3. So I could write this as u squared plus 8u plus 7 equals 0. And this is much easier to work with than this mess up here. Factoring this would give me u plus 7, u plus 1 equal to 0. Now that it's factored, I'm going to replace u with x to the 1/3. And now to solve, I'm going to set each equal to 0. For the first, I would subtract 7 from each side. and then cube each side. For the second, I would subtract 1 from each side, and then cube each side. So my two solutions are negative 343 and negative 1. Here's another. Again, these are getting trickier because my u in this case would actually be x to the negative first. X to the negative first. So that would leave me with 2 u squared, because if I squared that, that would give me to the negative 2, minus 7u plus 6 equals 0. This would require some tic-tac-toe factoring. Now that I have factored, I'm going to replace. So this is 2 to the x minus 1, x to the minus 1, minus 3, and then x to the negative 1 minus 2 equals 0. I would then set each of those equal to 0 to solve. To this point, now I have x to the negative 1 all by itself. And of course, to get rid of that, because that means that's 1 over x, remember that negative exponent means the reciprocal, I'm actually going to take each side to the negative first power. So taking this side to the negative first power, negative 1 times negative 1 is positive 1, so that's x to the first. 3/2 to the negative 1 says flip it upside down, so it's actually 2/3. Same thing for my second one. I'll add the 2. That's a positive 2. And then take it to the negative first power. To get x is 1/2. So I flipped 2 upside down. So my two solutions are 2/3 and also 1/2. Here's one for you to try on your own. So try this question, then press play to check your work. In this question, my u is actually x squared minus 6. So this would be u squared plus 33u plus 62 equal to 0. I'm looking for numbers that multiply to 62 that add to 33. So I'm going to use 31 and 2. So that's u plus 31, u plus 2. Replace u with x squared minus 6. And then, of course, I've got a little bit more work to do. So this minus 6 and plus 31 actually turns into 25. Minus 6 and plus 2 is, of course, minus 4. This second one does actually factor into x plus 2, x minus 2. But the first, because it's a plus in between, does not. So to solve, I set each of these equal to 0, setting x squared plus 25 equal to 0 is going to give me an imaginary number. So taking the square root of each side, I get plus or minus 5i. So my solutions are 5i, negative 5i, and then of course negative 2 and positive 2.